All right, referring to this figure, A3T66-6 in your book, and the figure you see in this slide, there are two 45-degree elbows and an offset of 10 inches used to set up some piping. The question is, what would be the length of pipe X? Okay, so let's first of all highlight the piping assembly. So this is your pipe here, and then we have a little angled piece here setting up the offset between this pipe and this pipe. And we know the offset is basically, as shown here, y, the dimension y, which is going to be equal to 10 inches. Right? So we have a 10-inch offset between pipe number 1 and pipe number 2. And to create the offset, we used a 45-degree elbow here and a 45-degree elbow there. So now we've clearly highlighted what the question's asking about, right? The question is really saying, what is this dimension X? What's the length of that diagonal piece in between the two offset horizontal pieces of piping? You got to rethink some of this and go back to your basic geometry. So I'm going to just clear all this up now, and I'm going to redraw a few things here. Because what you have is a nice little right-angled isosceles triangle with two 45-degree angles. And I can show you how that exists. So basically, you set up this triangle right here. Right there. See that triangle? Let's highlight it. Right there. Right there. And that triangle has a right angle, right? And has a 45-degree angle here and a 45-degree angle here. I can make this a little bit bigger if you like. And we already know that this side here is 10 inches. Now, when you have a right angle triangle with two equal 45-degree angles, it's very easy to figure out length X, which is actually the hypotenuse, right? The long side of this little isosceles triangle where you have two equal angles. And if you remember from geometry, without even getting into the Pythagorean theorem, which might be a complicated way of solving this problem, this type of triangle with the two 45-degree angles always takes on the shape 1, 1, root 2. 1, 1, root 2. It never changes. So over here, what we're saying is this side and this side are going to be equal lengths, and this will always be root 2 times whatever that length is of the other sides. 1, 1, root 2. So we can use that as a ratio to set up any calculation to find out the hypotenuse, which is, dimension X. So I'm just going to put in the actual numbers now. Take those out. Bring my highlight back in. And what do we know? We know that this is 10 inches, right? This is also 10 inches because they have to be equal as per our 1, 1, root 2 triangle. You know what this side's going to be? X. It's going to be equal to root 2 times 10. So once you calculate that, you're going to realize very quickly that root 2 times 10 is 14.14 inches. Very simple. Try to remember your 1, 1, root 2 triangle, which is always going to be a triangle with two equal 45-degree angles, a 90-degree angle there, and the sides will always take on dimensions of 1, 1, root 2. B is your answer.